In how many ways can 3x's, 3y's and 3z's be arranged so that no consecutive triple of the same letter appears? The question is not hard. Let me explain. So you have 3x given, 3y given and 3z's given. So in how many ways can you arrange them so that you do not have 3y together, 3x together or 3z together? Right? It should not appear together. Now, let the three conditions be like this. Let C1 be the arrangements where XXX appears. Right? Now, let C2 be the condition where arrangements where YYY appears. Let C3 be arrangements where ZZZ appears. Right? So out of the 9 alphabets given, you have these three as C1, C2, C3 and the corresponding arrangements. I hope C1, C2, C3 is clear to you. If not, pause the video and think now. Next, what is N here? N happens to be all possible arrangements of these 9 alphabets given. 3x, 3y, 3z and all possible arrangements. How many of them are there? So you have 9 alphabets in all. So it is 9 factorial by 3 factorial into 3 factorial into 3 factorial. Why? If you do not catch it here, then you must probably revisit multinomial theorem, right? Because x is repeating, y is repeating, z is repeating, each of them thrice. So we divide it by 3 factorial thrice. Now, so 9 factorial by 3 factorial whole cube. This happens to be n. What is n of C1? How many arrangements are there where XXX appears? So, something like this can happen. XXX, YZ, YZ, YZ. Or XXX, ZY, ZY, ZY. Or YZ, XXX, YZ, YZ. So you see, so on. In all these you have XXX together. So how many such possibilities are there? You see, I'm going to consider XXX as one unit and the remaining 6 alphabets as individual 6 alphabets. So it is 6 plus 1 unit, which happens to be, and the number of arrangements of these happens to be 7 factorial divided by 3 factorial into 3 factorial. Why? Because you have 3 y's and 3 z's, right? So XXX I had considered to be 1 unit. So we are not dividing 3 factorial thrice here. Observe here. So n of C1 happens to be 7 factorial by 3 factorial into 3 factorial. Now, don't you think it is the same for n of C2 and n of C3 as well? Because I can write it as x, y, 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 xz, xz and x. So I'm again having here y, y, y as 1 unit and the rest 6 of them as individual units, which happens to be 7 factorial by 3 factorial into 3 factorial. Same holds true for C3 as well. So n of C1, n of C2 and n of C3 are 7 factorial by 3 factorial into 3 factorial. Well, now what is n of C1, C2? Now we have to consider those arrangements where XXX and YYY will appear. So it is going to look something like this. XXX, Z, YYY, ZZ. Or Z, XXX, YYY, ZZ. Do you see? Something like this should happen. XXX and YYY both should come together. So now I'm going to consider XXX as 1 unit, YYY as another unit and these Z's as separate units. So how many entities do we have? We have 5 in all. So it happens to be 5 factorial by 3 factorial. Now n of C2 is n of C2 C3 and n of C1 C3 will be on the same lines. What is n of C2 C3? N of C2 C3 will be those arrangements where YYY and ZZZ will appear, right? So it's going to be something like this: xx, y, z, z, and then x, or x, y, x, z, and another x. So this can be done in 5 factorial by 3 factorial ways, because I've considered y, and z to be 2 units and the rest 3 of them for x's. The same holds true for n of C3 as well. You can probably try enumerating 1 or 2 of them. What is n of C1, C2, C3? Well, those arrangements where xxx, y, and z will appear. We want those arrangements. Let me try showing you how it is going to look like. Well, xxx, y, z. This is one such possibility. Now, I'm going to consider xxx as 1 unit, y as 1 unit, and z as another unit. So I have 3 units in all. Now, in how many ways can I rearrange them? It is very obvious to see that it is 3 factorial ways, right? So, n of C1, C2, C3 happens to be 3 factorial. You can probably understand it like this. If I represent xxx as say A, y as B, and z as C, in how many ways can I arrange ABC then? The answer is 3 factorial, right? Now, so what is the answer for the question? The question was, in how many ways can these 9 alphabets be arranged so that no consecutive triple of the same letter appears? So basically we were trying to ask what is n of C1 bar, C2 bar and C3 bar, which is n minus n of C1 plus n of C2 plus n of C3 plus n of C1 C2 plus n of C2 C3 plus n of C1 C3 minus n of C1 C2 C3. So the answer goes like this. N of C1 bar, C2 bar, C3 bar happens to be 9 factorial by 3 factorial whole cube minus 3 times 7 factorial by 3 factorial whole square plus 3 times 5 factorial by 3 factorial minus 3 factorial. Again, you need not expand it and leave this as the final answer.